Hello students, welcome back to classes on computer organization. The next concept is about multiple bus organization. So earlier we have discussed about the single bus organization. In the some of the disadvantages of single bus organization is only one data word can be transferred over a bus in the given interval of time. Simultaneous transmission is not possible. Only one data word at a time can is possible to transfer over single bus. But in case of multiple bus, if you go with a multiple data path, then what will happen? You can go for concurrent data transmission, right? So that's why what will happen? Obviously, the number of steps for the execution will be reduced, right? The time consumption for the execution also will be reduced. So in order to improve the execution speed, in order to reduce the number of steps for the execution, we can go for a configuration called as multiple bus organization. So multiple bus organization which contains the register file or set of register or group of register. So here the fetch phase can be done in a single step. Okay. Sorry, fetch phase. This takes three steps as usual, but execution can be done in single phase. How? Let us see here. Uh, Here the execution of a instruction, three operand instruction R4, R5, R6. Add R4, R5, R6. This can be done in a single stage. See here, only four steps are sufficient. Earlier we had seen the execution of two operand instruction using single data bus that was taking 7 steps total, 3 for fetch and 4 for execution. We have discussed about it, but now 3 plus 1, only 4 stages we can complete the execution of even 3 operand instruction. What is that then? See here, first 1 2 3 stages corresponds to fetch. Fourth one, so R4 and R5 outs are accessed separately. Select the content of R6, add, store the result back on R6 and complete the task. That is what at step 4. Better you check the diagram, you will come to know. See, this is the updated diagram for multiple data bus. 3 bus organization in the of the data path. 3 bus organization of the data path. This is called as bus A, bus B and bus C, right, are the 3 data bus we have considered. PC is there as usual. Incrementer is associated with PC just for the sake of incrementing purpose, addition a constant value 4. Then we have a general purpose register group. This group of register is called as register file here. So bidirectional, as you can see, arrow from bus C and output arrow towards bus B and A. Then ALU is there, obviously, to input ALU A and B, and R is the output towards bus C. We have instruction decoder, instruction register is there, MDR, MAR as usual. Okay. MAR is pressing unidirectional, MDR is bidirectional. You are aware of MDR is taking input from one bus, placing output towards to another bus, right? That means it can place two data word at two different locations concurrently, right? That is what the that's what the sequence or steps we are supposed to follow. Okay, so this configuration you should learn. Please note down this diagram, draw this diagram in your notebook. Okay, 3 bus organization of data path. There is an incrementer, there is a PC, register file, LU, instruction decoder, IR, MDR and MAR. Draw the arrow mark appropriately. Okay, then let us discuss about this. So if you go through the diagram, you will come to know content of PC PC is taken, so PC out that can be placed on B as per the diagram, right? PC in can take from bus C and out can be placed on bus B as per this diagram. So select the register R equal to B. Okay, so R is receiving the input from B. That means R can take multiple input. It can take either from A or from B. A is from actually from multiplexer, but that is not selected now. Directly the input is taken from B. What is B? What is B? You should be knowing what is B. B is the content from bus B. That's it, right? What is bus B content? PC content. That's it. Read the address value from a area. Increment the PC. How? Using incrementer. That's it. Wait for the memory function to be completed. Now corresponding MDR. MDR out B. Where is MDR? Here the MDR is, right? MDR out. Actually there are two outputs for MDR. One is for bus A and other one is for bus B. Actually now it is to be bus B to be selected. MDR out B. Again select the outcome of R for ALU. R equal to B, set R equal to B, and transfer the content onto instruction register IR in. That is about the fetch phase. Slightly you have to remember this fetch phase here. Now execution is simple. From register file there are multiple registers available in a single file. Okay, R4, R5, R6 is given in the example. So R4. Now R4 out, you are accessing the content from R4, place it on bus A. Since register file can place the data either on bus A or on bus B, you can choose anything. We have selected here R4 contents we are placing on bus A, R5 contents we are placing on bus B. See the diagram. Register from register file R4, each and every register has got two outputs. It can be placed on either bus A or on bus B. R4 content is we are placing on bus A, R5 content we are placing on bus B. That's it. See here, R4 out on A, R5 out on B. Select the content of A. Okay, select A. Select A is what? Go for addition. Select A. From bus B, directly input B is taken by ALU. For input A should be accessed. Input A is nothing but use select A. Constant 4 is not applicable now. Okay, constant 4 is not applicable. Whatever the value is there on bus A, just select it using signal select A. Obviously, another input provided onto ALU is B. So A and B are selected, given as a input for ALU. Go for addition. Go for addition. See, add. Result is transferred onto R6 as per our requirement. So R6 in to be activated. That's it. Okay. Please go through this explanation. You will come to know. If you have any difficulty or doubt, please ask. Okay. If you understand the diagram now, easily you can understand the steps. Another important topic from this module: multiple bus organization.